today's problem from complex analysis, and this problem from UPSC 2024 optional mathematics 2 paper. Okay, and the problem is very simple. This problem for 10 marks, and here it is given that if phi and psi are functions of x and y satisfying Laplace equation, okay, then show that f of z, which is given by p plus iq, generally f of z is written as u plus iv, here it is given that p plus iq, is an analytic function where p is given by del phi by del y minus del psi by del x, and q is given by del phi by del x plus del psi by del y. Okay, very simple problem from complex analysis, and we use two important result of complex analysis. The first one is Laplace equation. Laplace equation is given by nabla square phi. This is equal to 0, and since it is given that it is the function of xy, so we use it for 2 dimension. Okay, and for 2 dimension this is del 2 phi by del x2 plus del 2 phi by del y2, this is equal to 0 if it given that it satisfies Laplace equation. Okay, and we use the condition of analyticity of a complex valued function f of z. We know that from Cauchy Riemann equation, we know that f of z, this is equal to u plus iv, is analytic if u and v satisfy CR equation. What is CR equation? CR equation, this means this is ux, this is vy, and uy, this is equal to vx. That is, we write this r as del u by del x, this is equal to del v by del y, and del u by del y, this is equal to minus del v by del x. This is the Cauchy Riemann equation. Now here it is given that phi and psi are satisfy Laplace equation. So in the first line of solution, since phi and psi satisfy Laplace equation, so we get nabla square phi, this is equal to 0, and we write it del 2 phi by del x2 plus del 2 phi by del y2, this is equal to 0, and let it be equation number 1. And similarly nabla square psi, this is equal to 0, so this is del 2 psi by del x2 plus del 2 psi by del y2, this is equal to 0, and this is 2. Okay, and it is given that we have to prove f of z, this is equal to p plus iq, is analytic. So if we prove that this function, that is p and q, satisfies CR equation, then we prove that f of z, this is equal to p plus iq, this is analytic. Okay, now we first differentiate p with respect to x. Here p means here u, so we get del p by del x. Now p is given by this, and put the value here of p, del x of, this is del phi by del y minus del psi by del x, and by differentiating we get this is del 2 phi by del x del y minus del 2 psi by del x 2. We name this relation as relation number 3. Okay, now again we differentiate v with respect to y, that is q with respect to y. So we get del q by del y, that is del y of, the value of q is given here, so del psi by del x plus del psi by del y. Sorry, this is the del phi, and differentiating we get del 2 phi by del x del y plus del 2 psi by del y2. This is 4. Okay. Now from 3 and 4, if we write px minus qy, this means del p by del x minus del q by del y. We get from 3 and 4, we get del 2 phi by del x del y minus del 2 psi by del x2 minus this is del 2 phi by del x del y minus plus del 2 psi by del y2. Okay, and this is not plus, this is minus, because here a minus. Okay, and clearly these two terms are cancelled out, and we get, actually this is not del x del y, we can write this is del y del x, del y del x, because here del phi by del x is here and we differentiate this term with respect to y. So this is del 2 phi by del y del x. Okay, and for any function phi, this is partial derivative exists. Okay, so the function whose partial derivative are continuous, and then we say that this function for the double derivative phi xy, this is equal to phi y x. Okay, we can interchange the order of derivative, that is the order of derivative is commutative since phi is or phi has continuous partial derivative. Okay, so we say that this and this are cancelled out, and now taking common negative, we get del 2 psi by del x2 plus del 2 psi by del y2, and clearly in 2 we get the relation del 2 psi by del x2 plus del 2 psi by del y2, this is equal to 0, so we get this is 0. Okay, and we get that this equal to 0, so del p by del x, this is equal to del q by del y. This is relation number 5. And in similar manner, as we prove relation number 5, that is the shear equation, first part of shear equation, we also prove, or we also easily we can prove that result as del p by del y plus del q by del x, this is equal to 0 by using relation number 1. Okay, and we write this relation as del p by del y, this is minus del q by del x, and we name this relation is relation number 6. Okay, and now we write here 5 and 6 shows that p and q satisfy shear equation. Okay, so the function or imply f of z, this is equal to p plus iq, must be analytic. Okay, this is our complete solution of this problem. Very easy problem from complex analysis. Thank you for watching.